Hi, welcome to Matcom. In this particular video, we will be seeing one problem from continuity and differentiability. This chapter is the part of NCERT Max Class Plus 2. It's a very long chapter. There are a lot of questions are there. Even in that particular chapter, this question is a very lengthy proposition. If you are able to solve this particular question, I think the many of the questions in continuity differentiability will be a simple cup of coffee because it's a very lengthier proposition. We will be using lot of ideas or lot of perspectives in order to solve such a question. So here, when we're considering that any function is given for differentiation, we can take it as let y is equal to x cos x. That means y is the function x cos x whole raised to x plus x sin x whole raised to 1 by x. Okay, since we have given two functions, because if you're considering first function, there is an algebraic factor, there is a trigonometric factor, there is a power factor which is raised, that is not even a number, they have given a variable itself. The second part also, there is an algebraic factor, there is a trigonometric factor, there is a power, that is also an algebraic factor. So it is very difficult to solve the question completely together. So we can consider this function as a two different function. Let u is equal to x cos x whole raised to x, and let v is equal to x sin x whole raised to 1 by x. So we can write it as y equal to u plus v. So if you differentiate the above equation or function with respect to x, means what you will get, dy by dx is equal to du by dx plus dv by dx. Clear? But we need to find out what is du by dx, what is dv by dx. Clear? So first we will consider the first function. Let u is equal to x cos x whole raised to x. See, we don't know how to proceed it. Be very careful whenever in any question, if the power is given as a variable now, you cannot proceed it directly. But if it is given a number now, you can do it, because we know that d by dx of x raised to n, if n is a number, means it will be equal to n into x raised to n minus 1. But here it is a variable, we cannot proceed like that. In those cases, what is the simplest way of approaching is that taking logarithm on both sides. Why? Because now we know logarithm of a raised to b equal to b log a. That means this power can be removed by taking logarithm. That is why we will be taking the logarithm. So if you take or taking logarithms on both sides, what will you get? Log u is equal to log x cos x whole raised to x. We know that log a raised to b equal to b log a. Therefore, log x cos x whole raised to x will be equal to x log x cos x. Logarithm of x cos x. Clear? Now you can take differentiation. So differentiate with respect to x. So what will you get? You are differentiating with respect to x. So I don't know whether you know it or not. The thing is that d by dx of log x equal to 1 by x. But here we need to find out logarithm of u. So what will you get? D by dx of log u will be equal to, d by dx of log u will be equal to 1 by u into du by dx. Why du by dx coming now? Whenever you are differentiating log x also, exactly what is the procedure now? We will be doing d by dx of log x equal to 1 by x into dx by dx. We should differentiate whatever may be the function coming inside. But dx by dx is 1. That is why we will be directly writing 1 by x. Otherwise, we need to do the differentiation of the inside function also. Here, when you're considering here, this particular system exists as a product of two different functions. For example, x is the first part, log x cos x is the second part. In that particular case, we use a law or rule in differentiation that is called a product rule. For example, if u and v are two different functions, means if you are if you are differentiating, that means if you are taking d by dx of two function, let it be u and v. U is the first function, v is the second function. Mean what you should do now? You should take the first function into derivative of the second function plus second function into derivative of the first function. Or you can directly write it as u into v dash. V dash means derivative of the second function plus v into u dash. U dash is the derivative of the first function. So if you use here, what is the first function? First function is x into d by dx of log x cos x plus into second function that is log x cos x, that is second function, into derivative of the second function d by dx of x, derivative of the second function. So when you come over here, you can understand the first function, that is x into what is d by dx of log x cos x. See, first you need to find out derivative of log x. That means logarithm of something. Derivative of logarithm is 1 by. So it is going to be 1 by x cos x. Why? Differentiation of log u is 1 by u, means differentiation of log x cos x will be 1 by x cos x. So now you need to differentiate the inside function. What is the inside function? Inside function is x cos x. So you need to find out d by dx of x cos x. Why I am not doing in this particular step? Because again you are getting a product function. So that we will be doing the next step. Plus logarithm of x cos x into dx by dx is 1. Dx by dx is 1. Here you can very clearly cancel out x and dx. So you will get 1 by cos x. So you will get 1 by cos x into what is the derivative of x cos x? See, derivative of x cos x is also two functions, x and cos x. So you need to again apply the product rule such that first function, that is x into d by dx of cos x plus second function into derivative of the first function plus logarithm of x cos x. So what will you get? You will be getting it as 1 by cos x into x into what is derivative of cos x? Derivative of cos x is minus sin x. D by dx of cos x is minus sin x plus cos x into d by dx by dx, that is equal to 1 plus logarithm of x cos x. Logarithm of x cos x. Clear? So what will you get? So you will be getting like, so this will be equal to so did we missed anything here? D by dx of log x logarithm of x cos x, that is equal to log x cos x. No, nothing missed. So 1 by x cos x. Okay, fine. So you will be getting it like minus x sin x divided by cos x plus cos x divided by cos x plus logarithm of x cos x. Sin x cos x cancel, you will get tan x. Correct? You will get tan x. So this is going to be minus x tan x plus 1 plus logarithm of x cos x. Logarithm of x cos x. So if you are simplifying it, you can write it as is equal to 1 minus x tan x plus logarithm of x cos x. What is this? This is nothing but equal to 1 by u into du by dx. Therefore, du by dx is equal to u into 1 minus x tan x plus logarithm of x cos x. Clear? What is u? U we assumed as x cos x whole raised to x. So what we can write? This can be written as x cos x whole raised to x into 1 minus x tan x plus logarithm of x cos x. Clear? Fine. So the first part is done. This is only the first part. We need to see the second part. What is the second part? V is equal to x sin x whole raised to 1 by x. I can understand that this particular part also, the power is a variable. So we can proceed only by taking the logarithm. So if you are taking logarithm on both sides, if you take logarithm on both sides, what will you get? You will get log v equal to logarithm of x sin x whole raised to 1 by x. We know that log a raised to b equal to b log a. So we can be written as 1 by x into logarithm of x sin x. So now we can differentiate. Differentiate with respect to x. What will you get? You will be differentiating d by dx of log v equal to d by dx of 1 by x into logarithm of x sin x. Logarithm of x sin x. Clear? So if you are differentiating log, it is going to be 1 by. So it is going to be 1 by v into dv by dx is equal to. Here it is a two function 1 by x and log x sin x. So you need to apply the product rule. What is the product rule? First function into derivative of second function plus second function into derivative of the first function. Fine, perfect. So if you take the first function, derivative of the second function, what is going to be? It is going to be derivative of logarithm of x sin x. So first we need to take the derivative of logarithm. Then what you will get? You will get 1 by x sin x into d by dx of x sin x plus second function. Sorry, this is over. Second function, that is logarithm of x sin x into derivative of 1 by x. See, when you want to find out derivative of 1 by x, d by dx of 1 by x is nothing but d by dx of x raised to minus 1. That means in the place of n, we have minus 1. So, d by dx of x raised to n is n into x raised to n minus 1. So, d by dx of x raised to minus 1 will become minus 1 into x raised to minus 1 minus 1. That is equal to minus 1 into x raised to minus 2. So this is become, if x raised to minus 2 going down, it will become minus 1 by x square. So it is going to be minus 1 by x square. Hope it's clear. Now we need to take this x sin x. This x sin x is also applied with the product rule. So what will you get? You will get 1 by x into 1 by x into 1 by x sin x into derivative of x sin x will be equal to first function x into d by dx of sin x plus second function into, that is sin x into d by dx of the first function. That is over, plus logarithm of x sin x into minus 1 by x square. So it will be minus will come into x square. Clear? Fine. So the next part is going to be what we can take. So if you take, okay, we will keep it 1 by x out itself. 1 by x into 1 by x sin x into x into derivative of sin x is cos x. Derivative of cos x is minus sin x. Derivative of sin x is cos x plus sin x into dx by dx. Derivative of x is 1. So it is equal to x cos x plus sin x minus logarithm of x sin x divided by x square. So if you apply here, if you open up the bracket, what you will get? 1 by x square sin x, 1 by x square sin x into x cos x plus sin x minus logarithm of x sin x divided by x square. Clear? So if you open up the bracket, it will come x cos x. You will be getting x cos x divided by x square sin x plus sin x divided by x square sin x minus logarithm of x sin x divided by x square. We can cancel out the sin x and sin x. We can cancel out sin x by sin x. If you cancel out cos x and if you cancel out cos x and sin x, you will be getting the cot x. If you cancel out cos x by sin x, you will be getting the cot x. Okay. So if you take x square as common, what will you be getting? When you are taking x square as common, you will get x cot x plus 1 minus log x sin x divided by x square. Fine. So you will be getting like x cot x plus 1 minus log x into sin x. Sorry, logarithm of x sin x. So I made a mistake. Please correct it over there. So in the above step, because x sin x was the function of logarithm, so we should not write it like this. It should be, please correct it, that it should be logarithm of x sin x. So it should be equal to logarithm of x sin x. If you take 1 at the beginning, it is going to be 1 minus logarithm of x sin x, 1 minus logarithm of x sin x plus x cot x divided by x square. 1 minus logarithm of x sin x plus x cot x divided by x square. So this is nothing but equal to 1 by v into dv by dx. So what you will get? So you will be getting 1 by v into dv by dx equal to 1 minus logarithm of x sin x plus x cot x divided by x square. Therefore, dv by dx is equal to v into 1 minus logarithm of x sin x plus x cot x divided by x square. What is v? V is x sin x whole raised to 1 by x. That is equal to x sin x whole raised to 1 by x into 1 minus log x sin x plus x cot x divided by x square. So we got dv by dx. We already calculated du by dx. What was du by dx? Du by dx was equal to x cos x whole raised to x into 1 minus x tan x plus logarithm of x cos x. Oh, there is a bracket. Please give the bracket. Logarithm of x sin x, because x sin x is the function of logarithm, not sin x is an individual function. So we should give the bracket. We should not miss it. So if you are taking it up everything together, so we know that dy by dx is equal to dv by dx plus du by dx. Therefore, dy by dx is equal to x cos x whole raised to x into 1 minus x tan x plus logarithm of x cos x plus dv by dx is x sin x whole raised to 1 by x into 1 minus logarithm of x sin x plus x cot x divided by x square. So our final answer will be x cos x whole raised to x 1 minus x tan x logarithm of x cos x plus x sin x whole raised to 1 by x into 1 minus log x sin x logarithm of x sin x plus x cot x whole divided by x square. This is the final dy by dx. So we came to understand too much of lengthier proposition is this. We have used many things. That means we used a product formula, that is d by dx of uv. U and your two function means the first function into derivative of the second function plus second function into derivative of the first function. We used it. We used the d by dx of logarithm of something. Log u will be equal to 1 by u into du by dx. We use d by dx of x raised to n is equal to n into x raised to n minus 1. So d by dx of x raised to minus 1 or d by dx of 1 by x is equal to minus 1 by x square. Derivative of sin x is cos x, derivative of cos x is minus sin x. We also used chain rule. Chain rule also we have used over there. So we have used a lot of proposition in order to solve this particular question. I hope the explanation is very clear. If you are not getting in one time, do watch this particular thing repeatedly, then you will understand. If you need any clarification in any one particular step, or if you need to see solution for any question from continuity and differentiability, or any question from chemistry and mathematics or physics, do let me know in the comment section. We will solve those questions. As a token of gratitude, please like to this particular video. Please subscribe to our channel. Keep watching, keep learning. Thanks for watching. Bye.